Hello everybody, this next video now is looking at making the bushing. So we're going to do the work play on the lathe. So the bushing, as you can see, fits into the flywheel. It's on the completed project. So it's a vital component as it's press fitted into the flywheel. If we look at that in more detail, this is the part itself that we're going to manufacture today. So that's our part. Again, get the material from the store. So you get your piece of material from the store. What we have to do basically is we need to drill a hole through here to match the diameter of the dry shaft, which is going to slide in to that part there. So that hole we're drilling is to match the diameter of the dry shaft and give it the correct nice H7 fit through it. We're to turn down two different collars. So if we look at our drawing, get those dimensions, we can see that in our booklets, our finished length of our bushing is 29 millimeters. When you get it from the store, the material is probably measuring about 32, 33 millimeters. So we have a couple of millimeters to machine off either side, either face, and it's symmetrical. So what we're going to do then is create an 8 millimeter shoulder in the bushing. So it's an 8 millimeter shoulder on this side, an 8 millimeter shoulder on this side, and the thickness of the center part matching here matches the thickness of your flywheel. So that's 13. So the 13 you see in the distance in here is matching the thickness of your flywheel. So to start this project, we're drilling the hole we're drilling through needs to be a correct tolerance, and the tolerance in that hole is a diameter 10 H7. So to do that, we need to drill the hole 9.5, 9.7, and then I'll be using a 10 reamer to give us the correct tight tolerance on that hole. So to start off, let's get this out of the way. You'll take your piece of material, pop it into the chuck, and allow it to slide overhang with the width of your thumb, which is about 20-30 millimeters. Set your tool height up on center, like always. Check your tool height with the revolving center. Make sure that it's on center. Once that's checked, move it back into machining mode for facing off the part. So step one, we're going to face off the fast bushing. So do your calculations and set your RPM. And if you're still in training, if that's 1200 is the max speed you're going to be using. So put the tool off the end of the part, up to your DRO, and set your reference. Press the button here to reference, and then Z to 0 and enter. Powering on the lathe. No need for the coolant for the video purposes. We'll power on the lathe, and it's going to face off the piece. What we're going to do here is about half millimeter off the face of it, so that's only less than a half millimeter. I'm taking off about 0.3 millimeter cut. And what I'm checking for is there's no pip. If your tool height's on center, you're not left with any pip in the center. That's perfect. No saw cuts left, and with no pip in the center. So now the next stage of the process, following our process plan, is to get ready for drilling. So we're going to remove the revolving center. And all the drill bits you get from the store that you need. Pop that in its holder, winding forward on the tailstock, 60 mil to allow the chuck in position. Tighten up your center drill bit, and we're creating a pilot hole for the 9.7 drill bit. So moving forward, apply on your tailstock lock, and you're going to drill forward into the corner of that center drill bit, creating a pilot hole for the 9.7, 9.5 drill bit. Either one will do, 9.5, 9.7, whichever one you can get from the store. So that's now done, and the next thing now is to drill 9.7 millimeter hole. I'm using a 9.7 drill bit. So adjust your speeds accordingly to your calculations. Apply on your coolant pump and position coolant on to the drill bit, not onto the work. So again, speed here, I'm going to go in training for you guys, is at 1200 RPM. So move up in the position of the hole, and we're drilling this hole straight through the part. So apply your lock on, leave off the quill lock, and only lock the tailstock lock. So this is the lock you want to make sure it's on. Only this lock is on. Don't apply this lock, only this one here. And you're drilling forward into that hole. And we're going to go straight through. So keep on moving with the tailstock. Don't lie stationary to avoid screeching, high-pitched noises. And you're just drilling in, winding in on the back tailstock. And then you'll feel then, if you break through, there'll be no resistance. So now we've broken through, drill it's gone straight through the part and back out again. Now the next step is to ream that hole we've just drilled. So we're going to remove out the chuck and take out the drill bit. So removing the drill bit from the chuck is always safe. Out of the way. And now taking your reamer and position it into its sleeve, and to apply that in you wind forward again 50-60 millimeters for it to click into place. So you wind forward, it just slots in. That's it. Push forward again. Now the rule for reaming is half the speed and twice the feed. So we're only going to take off 0.3 of a millimeter. We have 9.7 drilled off, and this gives us the correct tolerance of that H7. So turning on the lathe again at 1200 RPM, and you're powering on straight through. So twice the feed and back out. And that's all the drilling done. So that's all the drilling we've done. So I can leave that out of the way now. Now, we're going to move on to the next stage of the process. Is I want to create an 8 shoulder. So the length here is 8, and the diameter we're trying to achieve on that side there is 20. So we have to take off, it's currently measuring 25, so I have 5 millimeters to machine off on the diameter to create an 8 millimeter shoulder. So back over to the lathe, let's get set up. Touching the tool off the end of the part, 0 or Z. Then bringing the tool out and touching on the outside diameter to get our X reference point. So X, 0, and enter. And we're going to reduce this down by 5 millimeters to get us down to our correct diameter. And then we're moving in here. So you can take off about 2 millimeters of cut at a time. And we're going to use automatic feed as well today. So this plunger lever is pressed in, and then you're powering on the gear chain we're using here is AT8X, which is a 0.2 millimeter pitch, and the RPM is 1200 RPM. Powering on the lathe, and you can do the first one manually. And you're machining in here to 11 millimeters, just shy of 11, work up to a 10.5, 10.8. This is an 8 millimeter shoulder, so we're stopping shy there of 8, 7 points. Always check your drones to double check those. So 7.5 is fine for the first cut. So then you come back out and back in again, and use a bit of coolant to wash away the sword. So moving in, and you're going to get X down to 5. So I'm just now going to apply my automatic feed. And then manually go in the last distance. Now, if you want it to get it really accurately, to stop the machine, the tool is still touching the part. What we can do here is we can zero the X and take a measurement with our vernier calipers to see exactly what diameter that shoulder we created. So on that part there, we're just checking the diameter we've created, and it's showing us in there on that diameter. You can apply on your lock and slide off the vernier. Now, always good to start, before we start, just to recap again, is to zero, make sure we're reading in millimeters, zero your vernier, and reading again. You can catch it if you're left or right-handed, like so, and tightening the lock behind and sliding off. So I'm currently measuring 20.88, so I've got 0.88 millimeters left to come off that part. So from here, you simply just adjust in your 0.88 is exactly 20 millimeters. So 0.88 come off, and that will give us exactly 20. There we go. And we want to see Z here equal to 8. This is the final cut. And I'm going to manually go in now the last bit. Wait. There we go, perfectly on 8. Machining back out the way. And that's our first side done. Okay, so that's the first little bit, first stage done. What we're going to do now is we're going to machine the opposite side. Taking our part out, and we can see there we have a couple of little burrs on our parts that can need to get moved off, a bit of swarf on the outside. So popping our part and holding in the chuck like so. Catch in between the outside diameter here. Don't catch it by the end of the shoulder, you could damage it. Catch it at its maximum diameter between the 25. Now what we want to be able to do is, you want to be able to measure with your vernier that you can capture. If you can position this in a way that you're able to get your vernier in behind, like so, before we start, you're ensuring that you can get your vernier in there to take a measurement, because in the end we want to get this to the correct length, and the correct length here according to our drawings is going to be, we have our 8 done, we now need to go for a 13 here, and then our final section here is going to be 8 again, and the diameter we're going to go for on this side is to match the far side of 20. So it's 13 and 8. So as a good practice, and if you were at this from the start, mark out where you think the 13 should be using your verniers. Now I'm pretty close with there on the mark I've just created. So I'm just going to make that mark a little bit bigger. So as it's rotating now, we can see that's the line we don't want to go past for our first cut. So repeating the process, we have it held using the outer diameter 25 in the jaws. We're ensuring that the vernier can fit through the back, and we can get a reading, see our full length of our part is. Now, next step is to bring your cutting tool over. You should have the same, X should be the same from the last time. So I'm just going to touch the tool off the outside of the part, 0 my X for reference, go to the end of the part, touch the tool off the end of the part, 0 my Z for our reference. And I'm going to create a small little shoulder in here, similar to what I did before with the cam that will come up next, in the next videos. So now we're going to make a small cut. So I'm going to go in here, 2 mm cut in the X to give me a little shoulder to measure with my vernier calipers. You'll see in a second. So I'm going to power on the machine. And now I'm going to make a cut in here in this edge, start machining down. And I'm going to stop shine. I can clearly see that the blue line, we haven't gone past that 13 in the video. And what we want to do now is take your vernier. We're going to measure now 0 my Z, enter, and take a measurement of the vernier calipers. You can fit it in between here. And we see then that the current measurement at this stage in time is 15.63. So we've got 2.63 to come off, 2.6 to come off in the diameter. We'll take off 2.6, this leaves exactly with 13. Powering on your lathe, you've got 2.6 minutes come off here in the Z. Okay. 2.6 has come off. That leaves us exactly with our 13. So now we're going to zero the Z, and that gives us exactly 13 shoulder. The top of the lathe. And that now has given us, we have got our 8, we've got our 13, we're trying to achieve. We have our 13 created, and now we're going to concentrate on getting the opposite side here to the correct length. So moving back out, we see the length of the part. We see how much we've got left to take off. So it's measuring 10.905. Yours may vary slightly according to the part you got from the store. We're going to machine this down now to give it the 8mm. So we're not going to take it off in one cut. We got small cuts as we trace off the part, about a ½ mm at a time. So firing on the lathe, and we're going to go in and out making small cuts across our part, applying a small bit of coolant onto the tool. We're facing off that part, working it down to 8mm in length. We're at 10, 2mm come off left. So small cuts in and out, 1½ mm to go. Now, the final cut, take this back to 8, and that'll give us the final length of it. Final cut, just getting ready for it now. There we go, and it's the final cut. And now we can stop your lathe. So that's brilliant. We have now got our bushing measuring as we started out. We've created our 8, our 13, and now we've also got the upside perfectly symmetrical to 8 as well. We've drilled our hole through here, first with 9.7, and we reamed it with the 10. But what you can see there, as we move facing across the part, what happens is it can create a small bit of a lip. So we have that reamer still in position that we had from when we drilled the hole. And we're going to bring that forward again now, just to re-ream that little last section there to make sure there's no material left inside the hole diameter. So we're applying coolant. Just pause for a second. So we're just going to drill out that hole. And just making sure that's reamed straight away through. And you're going back out again with that reamer. Okay. Next thing now is to concentrate on, before we remove the part, make sure we have all the measurements done. We're going to concentrate on now on getting our diameter correct. So we have our lengths all right, 8, 13, 8. We have the first side done at 16. We're not machining that diameter there. And now we bring down this diameter here to match the opposite side, which is 20mm in diameter. So I'm going to touch the tool off the outside diameter, 0 or X. Get a reference point. Power on, machine, and now we're going to adjust in a millimeter of a cut and just start machining that down. But don't go past the 0 point here to cut anything from it. Otherwise you reduce down to 13. So let's stop side with about a ½ mm side. Close enough. Now we're going to 0 our X as the tool is touching. So the tool is touching. We reference the tool to measure our diameter, so I can back away now and take a measurement to see what diameter we're reading. Again, if you're left or right handed, apply on your lock and then sliding off. We're 21.64, so we've got 1.64mm come off the X diameter to make it 20. And here we go, we're going to adjust in 1.64 for our final cut. There we go, final cut, 1.6mm torque. I'm going to use automatic feed again, so this lever is pressed in, I engage the lever here to start it. I'm machining in, I'm going to stop shy about 2mm and finish it manually. I'm going to manually machine in the last section. Up to 0, right in close to it now. Take your time, you're machining in that point. There we go, perfect. And then just going to back away. That's our finished part. So as the part comes out, what we can clearly see on the piece here is we get these little bits of burrs built up on it. And a neat way of removing them is to do it using the 45-degree cutter. And it's what's called breaking the corners. I'm going to remove out the turning tool, we no longer need that. I'm going to pop in a 45-degree carbide cutter. So pop that into position. Again, always check the tool height is on center, so you can remove out the reamer, pop in your revolving center, and check your tool height is on center before you start. And the tips are lining up perfect, but always good to check. So now set the speed of the lathe to its highest setting of 2,500 RPM. And that makes the chuck really easy to rotate. And what we're going to do now is what's called breaking the corners. So breaking the corners, back on our drawing, is that we're not actually applying a chamfer, we're just literally breaking off the sharp edge off the corner. 1, 2, 3, 4, those 4 points. So when the chuck is free to rotate, you literally just bring the tool in, touch it right off the edge. So we're touching the cutter off the edge, tightening in here on the cross slide, and then all you do is just apply a bit of pressure in and then rotate the chuck down onto the part, allowing you to break the corners in the piece. So if you want to adjust it out slightly a bit more, so you can get into that edge here. And again, what you're just doing is you're just breaking the corners, so you're applying, rotating the chuck down onto it. Kind of breaking, it's called breaking the corners. That's one side done. Moving in then to that bit there and just rotating the cutter onto it, and it cleans up nicely. So a small little bit. And that's those two done. Then removing the tool, we're going to do the opposite side now. With those two parts done, nicely chamfered, there and there. And now what I want to do is the opposite side. Popping it back in. And you can literally just, again, bring the cutter back in again. And you're just rotating the chuck by hand. You're not turning the lathe on, just by hand. And that's what's called breaking the corners. So it's smoothing it up. And then in there again, that final stage. So you may have to reposition sometimes to make sure it's headed out a small bit more just to grip it. And we have then is created all the work on the lathe, and the next stage of this process will be to go over and to drill that hole to match. We have to drill a small little hole here, an M3 hole. We're going to drill it 2.5 and going to tap at M3, and that's done on the milling machine. We're going to, and another video to set up to do that with you. So that's all the work that's completed on the lathe. When you before you leave the stage, you're making to ensure that your handle is fitting in nice and freely into the part as slides through like so, and that's giving us a perfect fit, 8/7 onto that outside diameter bar. So we have 8 in length, diameter 6, diameter 20. We're just got the shoulder here to match the thickness of your flywheel, which is 13. And we didn't machine the outside diameter, and we made them both symmetrical. This is again 8 millimeters in length, diameter 20, and the hole you machine through is you drill it 9.7 and you ream it 10, and that matches the diameter of the dry shaft feeding through there. That part then will be press fitted into the flywheel, and that'll be machined down the CNC. Thank you very much.